Hello again everyone, my name is Mike Gag, and in this video we are going to be finishing up part 2 by looking at all of the graphical primitives, or the graphics primitives that we can draw with Allegro 5. Okay, so what we see here is Visual Studio 2010 and just our generic test code so far. This should all look very familiar to you, with the exception of these two variables here. I just wanted to make something simpler, so I added these two variables, width and height, and then I just substituted them in here for our create display. So our screen resolution will be 640 by 480. Now, starting with graphical primitives, we're going to look at the very most basic of all primitives, and that is the single pixel. Now, with all graphics primitives in Allegro 5, we need to include the primitives header file. I'm going to do that now. Pound include Allegro 5 slash, and there we go, primitives.h. Oh, that didn't work. There we go. Okay, perfect. Alright, and that's just letting the compiler know that we will be using primitives, surprisingly. Okay, so now that we have included the header file, the first thing we need to do is initialize the primitives add-on. This primitive add-on is what allows us to draw squares, lines, circles, rectangles, triangles, and the lowly pixel. So I'm going to do al init primitives add-on, and that allows us to begin. So this isn't going to be a very wow demo here. Basically, I'm going to call the function al draw pixel, and I'm going to pass in an x value of 100, a y value of 100, and a color of al map RGB. We'll say 255, comma 255 for hideous magenta, and like we assume, it is going to draw a single pixel at that location. And there it is. So nothing spectacular. I could draw a whole bunch of pixels. I could, make a loop here that drew a bunch of pixels in random places. But I just wanted to keep this simple because we have a lot more primitives to look at. So in a nutshell, that's pixel. We'll have better demos for the other ones. Okay, now it's time to look at lines, which is our second most basic primitive. Essentially, we're going to specify 2 points, and then Allegro is going to handle the connecting of the 2 points with the pixels. So you see here, I still have the Allegro primitives.h and the al init primitives add-on. I just removed the pixel code from the previous example, and let's go ahead and draw ourselves some lines. So if I want to do al draw line, that's the function that allows us to draw lines. Let's try 100, 100. So that specifies the first point 100, 100. And now we specify the second point. And so I want to make it, let's say, width minus 100, so we're 100 shy of the right edge, and then 100, which means this is going to be a horizontal line since the y values are the same. And then we specify a color. Let's do al map RGB. Let's do 25500. And then finally, we can specify the thickness of our line. This is just going to be one pixel's width. And I'm going to run that. And we're going to see our red line. Okay, nothing fantastic so far, all pretty basic. Let's try a different line here. Let's do al draw line, and this time we're going to specify 50, 200, and then width minus 50, and then 200, another horizontal line. Al map RGB, let's do 0, 0, 255, a blue line, and let's specify a bigger thickness. So we can test out to see what a 5 pixel thickness looks like. I'm going to run this here, and we can see much thicker than our first line. And finally, let's try al draw line. Let's go 0, 300. It's going to be all the way up against the left. 2 width, so it's going to be all the way up against the right. 300 AL map RGB. And we'll do my favorite, hideous magenta. Now, I do want to note, since we're going all the way up to width, the screen actually works like an array. Say our screen width is 640, it actually goes from 0 to 639. So we're actually going outside of our array here by going to width, but Allegro doesn't mind. It's okay working with screen objects. We can go out of bounds, and it's not a big deal. Later on, you might find working with bitmaps that's not okay, but for right now, that is fine. Objects are allowed to move into negative space, as it were, and things are contained. And then finally, we're going to specify 10 for our thickness, just to see a real thick line here. And I'm going to run this, and there we go, real thick line. And that will wrap up lines. Nothing too except, well, you know what? Let's do one more. Let's do AL draw line, and let's do let's say 50, comma 50. So our first point 50, comma 50. Let's do a vertical line. So 50, comma 400. Let's give it a color AL map RGB, and let's do 0, comma 255, comma 0 green, and our thickness can be 3. Wow. We'll run that, and there we go. Vertical line. You know, now that I think about it, that's kind of boring too. Let's do a diagonal line. Let's pick one of these and make it a diagonal. So let's take our second line here, and we'll just copy it. I don't want to overwrite it, so we have examples of each. And I'm just going to change this last one to say 400. All right. So that should have us in a downward sloping line. And there we go. Boom. Downward sloping line. So we got our vertical, horizontal, diagonal, and multiple thicknesses there. So that's lines. And it's nothing too crazy, you know, fairly basic stuff. So as long as you understand the coordinates, not too bad. Okay, we're going to move right on up the difficulty tree here. We just finished lines, so now we can look at the next evolution, which is triangles. And a little geometry for you here as far as computer graphics goes. All objects can be represented as triangles. Really, if you think about a square, it's just 2 triangles. A circle is just a large amount of very, very small triangles. Even in 3D, everything is representable by triangles. So triangles are actually, they make up most of what happens inside computer graphics. But we will learn to just draw them basically, and then use some more user-friendly functions to draw more complex shapes. So I have my AL init primitives add-on, and let's look at drawing a triangle here. I've got a couple different functions that we get to use here. So I'm going to do AL draw. And by the way, if you haven't noticed, all Allegro drawing functions begin with AL draw, so that's an easy way to keep it in your mind. So AL draw triangle. Let's specify our first point. You're going to notice we're going to actually specify 3 points, and then Allegro is going to connect them all. So I'm going to do 10 by 200. So that's our first point. I'm going to do 110. That's our second point. And then I'm going to go 190, 200. Just so you know, I'm not picking these out of my head. I actually pre-mapped them on graphing paper, which is actually a pretty good habit to get into if you're doing a lot of primitives or a lot of graphical art stuff. Now let's give this a color. Map RGB. And you know what? I'm going to go to a staple here and make it hideous magenta. And so that's our color. And then once again, we get to specify thickness. Now, the reason we get to specify thickness is because this is just drawing a triangle, right? So you'll see here, there's a triangle. It's hollow. It's just drawing a triangle. All right. If we want to fill it in, we have another function for that. That's AL draw fill triangle. No hollow triangles for us here. We're going to do 300, 400, 400, 200, lost my place, 500, 400. There we go. and AL map RGB, and let's do 0, 0, 255 blue. Now note, there is no thickness because it's filled in. There's no thickness of the line. The thickness is 100%. And we've got our hollow one, we've got our filled triangle, and we could not be happier. So yeah, triangles. You can make them turned. I just did all of mine as sort of upright triangles. But as long as you specify 3 valid points, Allegro will find a way to connect them and make them into a viable triangle. Okay, continuing on, we have rectangles. Little geometry lesson for those of you who don't know. Rectangle, 4 sides, 4 corners, very simple stuff. Essentially 2 triangles added together. So in Allegro, we're going to only need to specify 2 points, an upper left and a lower right hand corner, and it is going to combine them to make our rectangle. So let's look at this. We have AL, draw, no surprise there, rectangle. And let's specify our first point. I want to do 10, 10. Our second point will be 250, 250, and a color, AL map RGB. I could just do an AL map RGB to like a constant variable, so I didn't have to do this so often. But I like the typing practice. Keeps my fingers limber. We'll go to hideous magenta. I do prefer, and thickness 5. And let's go ahead and run that and see what we get. And just like the triangle, you'll see that it is hollow. We have a thickness because it is hollow. Because we just specified, hey, just give me any rectangle. We actually have a few, namely 4 functions that revolve around drawing rectangles. So let's look at the next one here. We got AL, draw, rounded rectangle. Rounded rectangle, yes, this one's pretty cool. You'll see here what we can do with this. So first off, I'm going to do width minus 200 for my first point, my x, 10 for my y, width minus 10 for my second x value, and 50 for my second y value. Now you'll notice the next variable, float rx, okay, and float ry. That's the radius of the x-axis, the radius of the y-axis for the rounding of our corners. So I'm going to make it real simple. I'm just going to do 5, 5. However, if I wanted to round in an oblong shape, I could do like 5, 10 or 12, 2 or something like that. And feel free to play around with that. And then let's do AL map RGB, and let's give it a color. I'm partial to following hideous magenta up with blue. And once again, we have a thickness because it's going to be hollow because we're just doing a rounded rectangle. Now let's do 15. Let's make this real thick, and I'm going to run it. And you can see, look at these rounded corners. Now they're square on the inside. Here, let me pull that back up again because I didn't get a chance to finish talking about it. Square on the inside, rounded on the outside, real cool looking. I could do thicker rounds, I could do thinner rounds, more acute, more obtuse, depending on those RX and RY values. Alright, so let's check the next one out. This is gonna seem pretty obvious. Filled rectangle, the obvious evolution of the standard rectangle. And let's give this some coordinates. I'm going to do 10 by 280, 250 by height. So we're making this go all the way to the bottom, or I'm sorry, height minus 10. So I lied, we're not going all the way to the bottom. And then I'm going to specify a color, AL map RGB, and we're going to give this the color. No, we're not. We're not going to give it any color. Color theory for you. White is the absence of color. Presence of light, absence of color. You'll win Jeopardy with that one. Alright, here we go. Just a nice white filled rectangle. Very fun. Okay. Last, but definitely not least, unless you never use it, in which case it is least, we're going to do, I'm sorry, I typed that wrong, AL filled rounded rectangle. Long function name. Bet you can guess what it does. Width minus 200. Y 180, and then width minus 10, height minus 10. We get to specify our RX and RY, and I'm going to do 10, 5. Just making it really weird. And let's specify a color. In this case, I'm going to do green. And we run it. And we get rounded corners are kind of weird shaped and a solid green. You notice the shape was a little off because I did different X or different RX and RY values. If I went the more traditional route with the 1010, see these are much more evenly rounded. So there you go, rectangles. Man, I'm just cruising through these. I feel like I'm on the power half hour. We are on to circles. Okay, circles, very much like triangles, has two functions. I bet you can guess what they are. And circles have some pretty neat things we can do with them. So I got AL, draw, circle. And in here, you see I've got CX, CY, and float R, and I'll explain that here. So first off, the X, and when I specify the X and Y value, I'm specifying the center of the circle. All right. Some other graphical standards, some other APIs have you specify in the upper left-hand corner of a circle, and it draws it from there. I am specifying the exact center of the circle, so I'm doing 100. 100 is the center of my circle, and then R is my radius. And I'm just going to do 50. That seems like a nice, neutral, innocent number. Soon to be corrupted by hideous magenta. Alright, and then I get to specify a thickness. And for my thickness, let's do something weird. Let's go 7. Why not? Alright. And there we go. Nice clean circle, 7 thickness, hideous magenta. Perfect. Alright. And the second variation of that, I'm sure you're able to figure out, is our filled circle version. We'll do 400, 400, and our radius 70. AL map RGB, and let's just make it 20. This one has no thickness because it is a filled circle. And boom, filled circle. Bigger radius, bigger circle. Okay, this one is 20 pixels bigger. Now I'm sure you noticed, or I hope you noticed, that we specified an X value, a Y value, and a radius for our circles, and that was essentially it. And that's all well and good for drawing circles, but if you think to yourself, hey, what if I wanted to make a game where a guy threw a football, right? Well, football's not round. Football is actually the shape of an ellipse or an oval, and that is something you can't do with that function. So the smart folks behind Allegro decided to help us out here, and they gave us a function called draw ellipse. And with draw ellipse, we can specify the things that make an ellipse, namely a radius X value and a radius Y value. So if I'm going to do 100 for my radius X, I'll do 50 for my radius Y, and then I will do AL map RGB for my color, and I'm going to just do something really wacky. Why not? That looks great. Alright. Oh, I'm sorry, I forgot to specify a thickness. And let's do 6. Now, that will give us the outline of kind of a dark maroon oval shape. 100 width, and let me pull this back up. The radius along the X is 100, radius along the Y is 50, so it's twice as long as it is tall. Our next function, as I'm sure you can guess, map, draw, fill ellipse, and let's do 400, 250, and then our RX or RY, let's do 100, 200. Make it taller than it is. And for our color, and let's give it a color, let's do 0, 255, 255. No thickness, because this time, once again, it's filled in. Oh, what I do. I forgot a parenthesis, I apologize. The videos are no longer perfect. And you can see here, twice as tall it is as wide. Radius X, 100, radius Y, 200. We get that nice Easter egg shape. Not bad for ellipses. Alright, our last primitive is kind of a weird one. It's called a spline. And essentially, a spline is a line that gets all curvy on us. So if we wanted to make like a spiral or a wavy line or something like that, we can do that with something called a spline. Now to pass into or to create a spline, we need an array of points. And Allegro will draw a line gradually easing its way through curves to meet all of these points. So let's go ahead and try one of these out. So I'm going to try float points array equals, and let's give it some values here. Let's do 0, 0. So we're going to start at the origin, 400, 100, 50, 200, and then let's end at the very bottom with height. Obviously these have to be in pairs because they are coordinates. And let's try draw. Draw spline. And I'm going to pass in my my array, as you can see here, of 8 points. Pass in points. And let's give it a color. Again, time calls for case magenta. And a thickness. We'll just do 1. Very basic. And we run it. And look at that. Curves through our points. Nice, neat spline. Very, very cool. Alright, let's try a second. Call this points 2. And let's just make it go all sorts of nuts. I'm going to go 0, height. So start at the lower left hand corner. 200. Oh, that would be weird, double on. 200, 100, 400, 200, width, height. And we'll call our function again, draw spline, pass in points 2, comma, Allegro color, map RGB, 0, 2, 5, 0, and let's give it a thickness of, say, 3. Alright, and, oh, I did AP, AL map RGB, okay. We run this, and look at that, just this nice, cool arced line there. Alright, that finishes up our video on graphical primitives in Allegro 5. I know it's a lot of information, a lot of functions you need to know. Luckily you can pause and rewind and go back to this video. Very important stuff. Over time you're going to learn to replace the graphical primitives with things like bitmaps and sprites and stuff like that. But in a prototyping phase, when you're working on the concept of the game, graphical primitives are fast and they're easy to plug in. Maybe your artists haven't finished your bitmaps or whatever to put into the game. Graphical primitives make a very nice way to test things out and play around with your different game concepts. So very important to know, and I appreciate you spending the time to watch the video.